Section 5.4 Interactive Assignment Objective 2. Suppose there is a 29.8% probability that a randomly selected person aged 30 years or older is a jogger. In addition, there is a 20.7% probability that a randomly selected person aged 30 years or older is male, given that he or she jogs. What is the probability that a randomly selected person aged 30 years or older is male and jogs? Would it be unusual to randomly select a person aged 30 years or older who is male and jogs? Okay, so here's our question. Okay, the first thing we need to identify is that the general multiplication rule states that the probability that two events E and F both occur is the probability of event E occurring times the probability of an event F occurring, given the occurrence of E. So we want to find the probability of E and F. This is the formula, which is equal to probability of event E times the probability of event F, provided that event E has already occurred. So therefore, the probability that a randomly selected person 30 years or older is male and jogs can be found using the rule below. So again, we're looking for the following. We're looking for the question. It's saying that what is the probability that a randomly selected person aged 30 years or older, okay, is the following. That means we're looking for the probability of a male who is a jogger, okay, is equal to the probability of a person who jogs. In the first sentence, it tells us that 29.8% probability that a randomly selected person aged 30 years or older is a jogger. Okay, and then in addition, we can see that it's going to be times the probability that a person who is a jogger is male. So it says in addition here, there is a 20.7% probability that a randomly selected person aged 30 years or older is male, given that he or she jogs. So that would be this probability. So let's keep in mind here, now what does the probability of a person who is a jogger represent? Was 29.8%, highlighted in yellow. Converting it to a decimal is 0.298. The probability of a male, where given the person who is a jogger, is listed as 20.7%, and we're going to change that to a decimal, which is 0.207. So now here we want to be able to find the formula. The probability of a male who is a jogger is equal to the probability of a person who jogs times the probability of a male, given that the person who is a jogger. So we're going to put in our values. We know that we have 0.298. We're multiplying that by 0.207. And then we're going to get the following amount where we need to round that to 3 decimal places. So we get 0.062. So we can see in our result that that's what we get, 0.062 rounded to 3 decimal places. Now the next question is, would it be unusual? Okay, well, let's take a look at that. For it to be unusual, an event is considered unusual if its probability is less than 5%. So we're going to take a look at this probability that we have up here, which is 0.062, and we're going to compare that. So the probability of a male who is a jogger versus 5%. Well, we found that that result is 0.062, which is greater than 0.05. And if it's greater than, then we would say, no, it is not unusual. So the probability is greater than 5%, so it would be considered not unusual.